and good afternoon. I feel honored to be one of the presenters today, and I will be presenting the HPV genotyping in assessing the impact of HPV vaccination. And it was done here at Karolinska Institutet, and I have no conflicts of interest. But since we are talking about and we have some history, I will go back to where Ola was a few talks ago with RDBH, reverse dot plot hybridization, versus Luminex, which is the method we are using today. So the PCR was the same, and then we did EIA to see which one was positive or negative, and after that we did the RDBH on the EIA positive samples. And this could take up to 5 days due to a lot of incubations. And 13 years ago, today, actually, Joachim, after validation, decided that we should change method. And this was actually done in the SwedeScreen study that we have heard some talks about today. So since 13 years ago, we now do PCR and then Luminex. So we do Luminex on all samples from the PCR, not only the positive. We don't know. And the differences between RDBH and Luminex is that at that time we could type 14 HPV types, and that was the high risks. Today we have 42 HPV types in our test up here, and it's an in-house, so we could actually add if it's some type that we are more interested in. It took 2 days just to do the hybridization. Today it takes about half a day. We got the result as dots, and it was manual reading. Today we get it as MFI values, which is fluorescence, and the reading is done by the computer that also calculates the background. The beta globin was included, though it was a separate PCR. Today the beta globin is not included. It's a real-time PCR. And this is what it could look like. And this picture is actually from SwedeScreen. So you see 27 and 28, 29, they are fairly okay to read. 30 is a bit darker, but this is what it looked like. And then beside there, I put what types they are. So this is how I knew, Ola, what type it was. And today, so after the 4th of April 2006, this is what it looks like now. We get the results and also the gray zone. So to the background to the study and the data I will present today, the Swedish National Cervical Screening Register, NKCX, collects and evaluates nationwide comprehensive data as basis for optimization of organized cervical cancer prevention in Sweden. And genotype from pathological blocks can also be very important for the registry. So what we did was that we identified and requested all FFP blocks during a 10-year period of cervical cancers here in Sweden, 2002 to 2011, and requested the blocks. We received almost 3,000 samples that were genotyped here in Huddinge. And for each case block, we also had a blank block as a contamination control. And when the section was done, it was also made slides that were stained, and I will go back to them in a while here. All blocks were extracted by a silane-free method, and we had a valid result for 2,850 cases. And with valid result, I mean that the blank block was negative for both HPV and beta globin, and the case block were positive for beta globin. So the data collection was done. We requested the blocks. Not all blocks were sent to us. We did genotyping and beta globin. And for the cases that were beta globin positive and HPV positive, they were valid, and we didn't do anything else. For the samples that were valid HPV negative, We took the slides that were done in the sectioning. We had a pathologist look at them to re-review, so to confirm that we had cervical cancer. If so, we tested them with real-time PCR for HPV 16 and 18. And this time, the Luminex and the PCR we have the primer target at L1, but for the real-time PCR, we have E7 for HPV 16 and E6 for HPV 18. And if the cases were not confirmed to be cervical cancer, they were excluded. So in the end, we had final result from both Luminex and real-time PCR. So here you can see almost 69% of all requested blocks were sent to us, and we have genotyped and have a valid result for 97% of all received. 82 cases were excluded, and it was due to technical issues, more than one block per woman, or not invasive cervical cancer. When we did the real-time PCR, we found additionally 89 cases, and in the end we had 14% that were HPV negative. And when looking at the results, HPV 16 is the most common type, followed by 18. And you can also see that most of the cancer has a single HPV type, but there are some cases that have multiple infections. 16 is the most common one. But I can also mention that all of these that had multiple HPV types, at least one of them were high risk. And when taking our data from the tumor, and now we only took the single type and only the types that were included in the vaccine, so we have not taken any cross protection or anything, we could see that the bivalent and quadrivalent vaccine would protect, theoretically, 66% of all valid cases, so also included the negative. And when only looking at the positive ones, it's about 79%. But when we look at the 9-valent, we would have a, theoretically, protection of 94% when looking at the positive, and 78% of all. But what about the negative tumors? Well, there seems to be some cervical cancers where it's hard to find the HPV with standard PCR. It also seems that women with high-risk HPV has a better prognosis than the one with a negative tumor. So this raises the question whether L1 negative tumors are biologically different from L1 positive tumors. So we went for sequencing. And here we tried both with and without PCR. We tried 2 different library kits for DNA. All libraries were validated, normalized, pooled, and diluted in the same way before sequencing. And the sequencing was done at NextSeq and 6 to 13 samples per run. So here is to try to illustrate all the ways we tried to do this to get a good result. But we were still not really happy with the results. We didn't get that many HPV reads, and we didn't get a result that we were happy with. So we asked ourselves, can we do something differently? Well, we did a pilot to try, even though it was DNA extracted samples and it was FFPE blocks, we tried the RNA. So total RNA, we used the true 6-stranded total RNA kit from Illumina. The libraries were treated in the same way as before, with the pooled and diluted, and we used the NextSeq. And we got more reads for HPV. We also got 50%, so 3 of our samples became positive for HPV. So with that knowledge, we said that, okay, so let's skip the DNA libraries and go for RNA and no amplification. So we matched 63 cases, were matched on histology and age. 30 of them were L1 positive in the Luminex, and 33 were negative. We also took, as this was a valid result, we knew that the blank block was negative. So we pulled the 32 first blank blocks into negative control number 1 and the 31 last blank blocks into negative control number 2. We did the library using the Smart Pico kit, and the sequencing this time was performed at NextSec, and this was just to keep the same depth, even though we had more samples. And we got more than 3 billion reads in total. Our quality score was very high, more than 90% of the reads, and 36,000 reads were HPV. And this was a good result. And when looking at these, when we started looking at the samples that were positive, we could confirm 28 of them. One that had become HPV 16 by PCR became 33 in sequencing, and one was actually negative in the sequencing. But when looking at the 33 negatives one, 15 positive became positive with the sequencing, and the most common type here was 33. But 18 was still negative in the sequencing. And when looking at why didn't we catch these ones in the PCR, six of the cases should have been found. One cases were positive for a test for a type that we didn't test for, HPV 85, so that can be explained. But then we had 9 cases that we didn't have any reads in the probe and primer sequence. So partial genomes, or? We were also interested in what are we sequencing. We know that it's FFPE and it's DNA extracted. So we looked at the spliced transcript, and we do have RNA. We also looked at the beta-actin, and here we wanted to have peaks over the exons, but we do also have peaks for the introns. So we have a mix of DNA and RNA. So to conclude this is still one of the largest studies of cervical cancer HPV genotyped. And the bivalent and quadrivalent vaccine was found to protect about 79% of the positive cases. And when taking the 9-valent, it was about to protect 94%. And when we take the sequencing, we get more reads, HPV reads, by doing RNA libraries. The negativity was unclear in 6 of our samples. And it appears that some late-stage cancer do contain HPV, but we have a hard time finding it with standard PCR. And advanced analysis by reference laboratory is essential for adequate quality when doing HPV-based cervical screening. And with this, I would like to thank everyone in the Access group, and also, of course, everyone in the Dillner group. And last but not least, the one, Carina Eklund, that is celebrating 30 years in the group today. Thank you.